Hi everyone, in today's lesson we're going to talk about derivatives of inverse functions. Two functions are said to be inverses of each other if they are symmetric about the line y equals x. And remember, to reflect one function to its inverse, we simply switch the x and y values. So there are three ways that we can represent the notation inverse, using f negative 1 of x, or simply saying in words g of x is the inverse of f of x, or by the true definition of an inverse, which is the composition of the two functions should equal x. So g of f of x equals x, and f of g of x equals x. So basically, all these three things are three different ways to represent the inverse. Now, this is the textbook definition of an inverse. This is the notation, and then this is just simply how you would write it. So I could see this coming up maybe on an AP exam where they would say, g of f of x equals x and f of g of x equals x. Then that implication is that f and g are inverses of each other. So maybe we should write that. If this is true and that is true, then f of x and g of x are inverses of each other. Okay, now let's work with the notation. So if I have f of negative 3 equals 2, we know that that corresponds to a point negative 3, 2, right? I plug in negative 3, I get out 2. But now I have this f negative 1 notation. That means inverse. So this point is really 5, negative 4. But that's the point on the inverse, on f prime of x. So if I want to know that what this corresponds to on f of x, we simply switch the x and the y values. So the y value is now, the x value is now negative 4, and the y value is now 5, right? So we're just switching it. So if I give you the inverse notation, this point is on the inverse, but this point, the opposite, flipping them, is on the original function. Okay, let's talk about how to take the derivative of an inverse function. So if I want to take the derivative, d dx, of an inverse function, the rule says it's 1 over f prime. That's a small prime, so make it a little bit bigger so you can see. So it's the f prime, the derivative of the inverse on the inside. So this is a composition of functions as well. So let's see how this all pans out with an example. Okay, so they give you a table of values with x, f of x, and f prime of x. And they first ask you to evaluate g negative 1 of x. This is actually a typo. I actually want you to evaluate g prime of 1. So they define g of x, right? They define g of x to be negative 1 of x. So they're saying g of x is the inverse of f. So when they say find g prime of 1, they're really asking you to evaluate this derivative of the inverse. So they want you to find d dx, the derivative of f negative 1 of 1. So we're simply going to use the formula above. So we see that it's 1 over, so 1 over f prime of f negative 1 of 1. So the prime is the derivative and the negative 1 is the inverse. So let's keep going. 1 over f prime of f negative 1 of 1. Let's find that first. So that is the inverse of 1. So what you're actually looking for in this chart is that I know it looks like it's in the x value, but you're really looking for the y value to be 1, right? Because it's the inverse. So you're looking for a y value to be 1, not the derivative, the y value to be 1. And that happens here. So that means my x value is 2. So let's just write this out. If x is 2, 1, that is f of 2 equals 1. But if I want to go backwards and switch the x and the y values and say 1, 2, then this would be f negative 1 of 1 equals 2. So they're inverses. So again, we're switching the x and switching the y. So when I say f negative 1 of 1, we know that that really equals 2. Again, you're looking for the y value of 1 and finding the x instead. So f prime of 2. Now f prime is this column here. So f prime of 2, when x is 2, y is negative 2. So 1 over negative 2. All right, so f prime of 2 is what is the y value on f prime of x when x is 2. So x is 2, y is negative 2. So that's where I got that from. Okay, let's take a look at example number 2 here. It says, write the equation of the tangent line to f negative 1 of x at x equals 1. So remember, a tangent line is, we need a point and a slope. We already found the slope in step 1. The slope was here. So the slope we know is negative 1/2. So we need to find the point. And the way that we find the point is we're not looking at x equals 1 and saying the point is 1, 3. Because this is on the inverse, we're actually looking for a y value to be 1. Remember, we switched the x and the y. So we're looking for our y value to be 1, which is here, and my x value there is 2. So that corresponds to the point 1, 2. So remember, it's the inverse. So the y value is my x, and my x value is my y. So we're switching the x and the y value. So x, y, rather than x, y. So my point, like I said here, is 1, 2. So my y minus y1 equals mx minus x1. So y minus 2 equals negative 1/2, and then x minus 1. And that is it. Okay, let's take a look at example number 2. They say if f of x equals this function and g of x is the inverse of x, what is the value of g prime of 25? So in order to be successful with this question, we have to understand that they're telling you g is the inverse of f. So if they're asking for g prime of 25, they're really asking for, prime means derivative, so they're really asking for the derivative, d dx, of f inverse of 25, right? Because g is the inverse of f. So let's write down that and use the formula. So d dx is f negative 1 of 25. That's what we want to find. So we're going to use the same formula as we did on the first page, which is 1 over f prime of f inverse of 25. So we want to ask ourselves, what do we need to finish the problem? We're going to have to do f prime of some value, but I only have an f of x function. So maybe the first thing that I should do is have a derivative somewhere. So f of x is equal to 3x to the third plus 1. And f prime of x, my derivative, is simply a power rule, 9x squared. Okay, so we have that when we need it. And we're eventually going to also need to find f inverse of 25. So I know that if my f inverse of 25, this x value, so to speak, is really my y value. So what I can do now is put this y value in for this y value and solve. So let's do that as my second step. So I have 25 equals 3x to the third plus 1. So quickly solve this by minusing 1 on both sides. Divide the 3 and take the cube root. Cube root of 8 is 2. So this tells me that if I have a y value of 25, that x value is 2. So we're almost there now. We can fill in this information. 1 over f prime of 2. And, right, because this piece, this was the work here, this inverse gives me that. So that's why I put that in here. And now I want to say 1 over f prime of 2. So I'm going to go ahead back here, and I'm going to put 2 in for my derivative. So 9 times 2 squared. So 36. 2 squared is 4, and then 36. So the final answer here is 1 over 36. And that's it. Okay, so now I think is a good time for you guys to try through some of these problems on your own. I know they're a little tricky and confusing, but just keep in mind that the inverse means to switch the x and the y values. So you're going to try example number 3 for homework and example number 4 for homework. Just do the best that you can and try them, and then we're going to start class by going over those tomorrow. All right? Have a good night.